Welcome to Brain Vision.
So here for part A, it is quite simple. We simply are just solving for the moment of inertia for a cylinder. This would be equal to 1/2 mr squared. And we can solve 1/2 times 0.380 kilograms multiplied by 0.0850 meters quantity squared. And we find that the moment of inertia of the cylinder is going to be equal to 1.373, or we can round to 1.37 times 10 to the negative third kilograms meters squared. For part B, we know that the wheel slows down on its own from 1500 RPMs to rest in 55 seconds. So we can say the frictional torque would be equal to the moment of inertia times the angular acceleration due to friction, or the angular deceleration due to friction. This would be equal to I delta omega, the change in angular velocity with respect to time. So this would be equal to 1.373. Rather, let's do a new line. 1.373 times 10 to the negative third kilogram meters squared. We're going to multiply this by 0.100 RPMs. So this would be our final angular velocity of 0, our initial angular velocity of 1500 revolutions per minute, multiplied by 2 pi radians for every 1 revolution. And then for every 1 minute, we have 60 seconds. And then this entire thing would be divided by 55.0 seconds. And we find that the frictional torque will be equal to negative 3.92 times 10 to the negative third Newton meters. This would be our final answer for part B. For part C now, or rather, continuing part B, we want to find the net torque causing the angular acceleration the net torque that causes the angular acceleration would be the applied torque plus the negative frictional torque. So we can say that the net torque is going to be equal to the applied torque plus the frictional torque, which we have just solved. And this would be equal to I, the moment of inertia, times the angular acceleration. Therefore, the applied torque would be equal to the moment of inertia times the angular acceleration minus the frictional torque. This would be equal to, again, I times delta omega over delta t minus the frictional torque. Let's solve. So the applied torque would then be equal to 1.373 times 10 to the negative third kilogram meters squared, multiplied this by 1750 RPMs. This would be the final angular velocity minus the initial angular velocity of 0, multiplied by 2 pi radians for every 1 revolution, multiplied by 1 minute for every 60 seconds. And then we're going to divide this entire thing by 5.0 seconds. 5.00 seconds, so 3 significant figures. And then we're going to subtract the frictional torque of negative 3.921 times 10 to the negative third Newton meters. And we have the torque applied to be equal to 5.42 times 10 to the negative second Newton meters. So this would be the torque. This would be the torque applied needed in order to overcome the frictional torque and accelerate to 1,750 RPMs in 5.0 seconds. That is the end of the solution. Thank you for watching.